Okay, is everybody here? I hope so. Let's just close the door then. Ej, det eneste, der mangler. Great, I think we will get started. Welcome to this session. I'm happy to see that so many people actually showed up. I was not sure if people wanted to hear about this topic, if it actually mattered out at where you work, but it's good to see that there is some interest for this. In this session we'll be speaking of TypeScript and also a little bit about the features in the new version of Visual Studio that will support TypeScript. But before we dive into that, let me just tell you who I am. My name is Sebastian Brandes, and I work as a tech evangelist for Microsoft, which means that my job is basically to go out at events and conferences like the Dynamicweb Tech Conference and present material on the latest technologies of Microsoft. So I'm responsible for the evangelism efforts on app development and web development in Denmark, and I've got about 10 years of web development experience, starting all the way back from classic ASP. I sort of have a secret affair with Azure, meaning that I really like running jobs and workloads in Azure. I'm not sure we'll do that today, but maybe we'll see at the end of the session. You can follow me on Twitter if you might be interested in the tweets, all right. So my Twitter handle is SebastianBK, and I also have a blog where I will upload this presentation and also the recording of this presentation, okay? But let's get to it. So first of all, we'll speak of what TypeScript actually is. How many in here know what TypeScript is? Okay, not a lot of people. So I'm actually happy to see that not more people have raised their hands, because the session description says that what we'll do is to take an Angular app or develop an Angular app from scratch using TypeScript. But I tried to do that before, and when I sent in my session description for the program for this conference, I thought that was a great idea. Let's just build something from scratch and use Angular and use TypeScript and build it up. And I presented a session on that, but not a lot of people knew what TypeScript actually was and what it could do. So rather than just diving into building an app, I think we'll take a deeper look into what TypeScript actually is, what it offers, and why it's really cool to work with. So yeah, why use it? We'll do some demo, and after the demo, we'll do more demo. And after we've done some more demo, we'll do even more demo, okay, right? And after that, we'll wrap up. And when we've wrapped up, we'll do more demo, and then we'll wrap up. Okay, so it's very demo intensive. I don't have many slides in this presentation. Great, so let's just get into it and start out with this statement. How many in here work with JavaScript? Almost everybody. How many in here work with JavaScript where it's not just sort of a single JavaScript file that you have that you use, like, I mean, large scale JavaScript development? Okay, quite some of you. How many of you know that that is hard to manage tons of different JavaScript files that might reference each other? Yeah, right. This is the problem we're trying to attack here, right? So large-scale JavaScript development is hard. JavaScript was developed over the course of 3 weeks back in the 90s, and I don't think the guy from Mozilla that actually developed or made this language thought it was going to evolve to where it is today, where we see code bases of more than 100,000 lines of code written in JavaScript. And the huge problem with those code bases is that sort of like as developers come and go and enter the project, and not everybody is sort of up to date with all the different corners of this huge 100,000 line of code JavaScript application. Well, this code base sort of becomes read-only. because nobody dares touch anything, right? Because who knows what will break if you do actually change anything, right? TypeScript is a language for large-scale JavaScript development. And more specifically, it's a strongly typed superset of JavaScript that compiles to plain JavaScript. Okay? So there's no magic here. There's no TypeScript there's no TypeScript runtime that will have to run on the platforms that you're interested in going out to, browsers or phones or whatever. This just compiles to plain JavaScript, and currently that is ECMAScript 5, which is sort of the standard for JavaScript as we know it today. There's a lot of talk about the new sort of standard for JavaScript called ECMAScript 6. How many are aware of that? Okay, some of those are, yeah, okay. So ECMAScript 6 has been sort of this new standard that there's been so much discussion about, and some of the things that will be introduced will be things like classes. That's sort of like the big thing. There will be sort of this lamp expression that we know from C# will also come, and like there's a bunch of other stuff, and but it's not around yet, and not any large browsers actually implement all of the features of ECMAScript 6 yet. So right now TypeScript compiles to what we know as JavaScript, which is really ECMAScript 5, and it runs in all the platforms that we're used to running JavaScript in right now. Okay? So no need to install anything. We don't need a TypeScript virtual machine or anything like that. It can run wherever JavaScript can run, namely because it is JavaScript that comes out of it. So why even use it? Well, the cool thing about TypeScript is that strongly typing our code can give us a lot of help, or it can enable the IDE that we'll be using to give us much more help when we're developing. It allows the IDE to reason about our code in a way that it can't if it's just dynamically typed, which that JavaScript is, right? So it's great for us developers when we sit and develop, but when we compile it, it compiles to plain JavaScript, and it can run in any browser, any host, any OS, and it's completely open source. So in a nutshell, TypeScript is just a compiler that takes something, we call that TypeScript, and it produces JavaScript. Okay? So it's JavaScript. We put types into it. Everybody here is familiar with types, right? Anybody not familiar with types? Good. Then we add some tools on top of that, because the tools, when our code is strongly typed, it allows for our tools to help us. So this is what TypeScript is. But at the end of the day, when we click that green play button and we compile the code, it's just JavaScript. Okay. So let's take a look at why it's cool. These are all the slides that I have, so if you thought the first 5 minutes were boring, I'll try to make it more fun for the rest of the presentation. Good. So let me just get out of here, and let's open up a new instance of Visual Studio. I have the latest version installed here, but this would work in 2013 as well. Rather than creating a new project, let's just open a new file. And let's make a TypeScript file here. So the common ending for TypeScript is just .ts. If you've got some JavaScript already now and you want to move over to TypeScript, you just have to do one thing, and that's rename your file to .ts, and you've got a TypeScript file. One thing that I'll say just before opening this file as well is that like JavaScript is valid TypeScript. So if you could just take all of your JavaScript, put it in a TypeScript file, and it's valid, right? So I'll give you an example of that. So the sort of small example I'll go through here, I'll build a small function. I'll start out by just writing it in JavaScript, and then I'll gradually add more and more types to this small script, and I hope it will sort of show how powerful TypeScript actually is. So the type of function I'll write is a sort function. It will take an array as an input, and it will also output an array, and it will sort the elements in the array by its name property. So let's try and do that. So we write a function, we'll call it sort by name, and it takes some input. Right? So we'll define this variable here, and so we have this result here, and we'll say sort. And does everybody know this sort function? You can either supply a compare function to it, or you cannot do it. It's a nullable function, but we'll apply or we'll send it an anonymous function here. So we'll compare these two objects, and the way we'll do that is we'll take the name property. We'll say local compare to the y name. Then we'll return this result. So this function here, just as I said, will take an array. It sort of assumes that the elements in the array has a name. Whoops. I'm missing. It sort of assumes that it's taking and that it has a name property, and then it compares that. And so why is this not? Oh, I wrote result twice. Stupid, right? Okay, return result. So this should go away, right? So this works. So it assumes that I give it an array of objects that all have a name property. But because this is dynamically typed, we can't really know that when we are developing this. So if I would just supply some number here, this would be totally fine. We can't detect this error that we've made here until runtime, right? So this sucks, especially if your code base is 100,000 lines and you're sitting with all these files and all this code, and you're trying to like wrap your head around it. But sometimes it's just really difficult to see that the error is there, right? So let's try to add types to this file gradually, and I say gradually because TypeScript is not sort of all or nothing. It's like either you don't have types or you have types all over the place. It's sort of like this knot that you can turn up, and the more you implement types in your script, the more help you get from the IDE. Okay, so the more you give to it, the more it can give you back. So let's try and do one little thing. Let's say that this input here, it shouldn't just be of type any. It should actually be an array of something. So we have this type here, which is any, which is basically just dynamic. It's just dynamic type. But we'll say we need something. We need an array of something. And you can see that the signature here of this function actually changes. Now it says that the sort by name function here takes an array of something and it returns an array. So now the IDE can help us a little more. We get this red squiggly line under the 5 here, and it says an argument of number or type number is not assignable to parameter of type any array. Okay. So does it make sense that implementing types actually is a great idea and that it helps us? I really think it should. So we could just give it an empty array, and now it will be happy. But still, like if we actually do look at the code, we know that we're going to get a runtime error if we try to do this, because this empty array obviously does not have any objects that have this name property on it. And that's sort of what we're assuming in our function. So what we can try and do will be to implement an interface. So let's try and do that up here. TypeScript comes with this concept of interfaces here, where you can define an interface and give it a name. Let's call it entity. And then for this interface, you can define some properties that it must have. So let's say that this entity must have a property called name. And obviously, because TypeScript is strongly typed, we would have to specify what kind of type this property is. And we'll say it's a string. Okay? Now, there's one important thing to note here, and that is that we're not nominally typing our objects, rather we're structurally typing our objects. So we'll say that if we instantiate any object that has a structure, that has a name property, then it implements the entity interface. Okay, so we don't have to explicitly write that, as long as the structure sort of fulfills the requirement of the interface, then we do implement the interface. Okay, so rather than saying we just want an array of anything, we'll say we want an array of entity, right? And let's say we should get an error. Well, first of all, we get this error, and I actually made this error on purpose. So it says here, if I can get the tooltip up. Come on, tooltip. Come on. Well, it says that there's nothing called local compare on a string, right? We know that this name now is a string because that's what we defined up in our interface. Well, if we press dot here, we can say there's something called locale compare, and that's obviously what I meant, right? So we can replace that, and we'll be happy here. This is the type of error that I see all the time, and I see developers like pull out their hair of their heads because of stupid typos all the time, and it's really hard to catch them because I'm pretty sure that nobody in here caught that error, right? I think somebody would have said something. So now that we know, or now that the IDE knows that this name property is of type string, it can go and check, okay, what methods does actually exist on this type? Well, there's nothing called local compare, so I'll complain about that and make the developer fix this typo. So that was great. Now, what will I try to do here? I think I'll try to, let me just see what I made sort of a demo script of what I wanted to show. Yeah, let's take a look at this interface a little more. So we can specify more properties to this interface. Let's say that this entity, let's think of this entity as sort of as a product that we might have in stock in our web store. So we would also want a price property here of type number, and let's then try to implement or let's try to instantiate an object that implements this interface. So we can say var and then to call it e for interface, and we'll say here, okay, this is of type entity, and we will now get a little bit of help from Visual Studio. So if I try to enter the name of a property here that I want to assign, then we get these two options, and obviously these two options come from here above, right? We can say name, and let's say let's call this 1, 2, 3, and let's say price is equal is 90.95. So now it does not accept that, and why doesn't it do this? No, it's actually, so the problem here is that we're trying to assign a number to something that's a string, right? So I really want to try to push this idea of strong types, right? This might have been totally valid in regular JavaScript, but it's not here, which it shouldn't. So let's try to give it a name. Let's call it a guitar. And actually also miss an equal sign. Good spot. So now we have this entity. I now have this this object of entity, and of course I can dot something we all know and love from C#, right? How many in here are C# developers as well? Quite a bunch of you. So this feeling, this experience will sound or will seem familiar to you, I would reckon. And we get a little bit of IntelliSense information. So we see that this price is actually a property and it's a number, right? So imagine again, think back to this 100,000 line of code application we have running. We instantiate an object that implements this interface, and we might not be 100% sure of what properties it actually has. And the definition for it might be, I don't know, 50,000 lines of code away. And if we were in a purely dynamic world, it would be a hassle to actually do this right. But because the IDE can now reason about our code, we get this information right where we need it, right? So imagine this this interface was very far away from where we're actually coding. We still get this information, okay? Yeah. If I were to delete this property, I would get an error. So this object that we have here, which is just one object that has a name property with the value guitar, it says that is actually not assignable to type entity. The property price is missing here, and it's not because we're normally saying that this is sort of, we're not saying that this is an entity, right? But the structure of this object does not match the interface of an entity, and that's why it knows that something is wrong here. So, well, if we add this back, then it will be happy because it can go and check that we properly assigned it. We properly assigned a string to the name property and a number to the price property. We also have the option to add nullable properties here. So let's say, think again that this entity is some product that we might have in our web store, and let's say that we would want to say if it's in stock or not. So we'll say we have this in stock property. Once again, this will complain here because this object here does not structurally implement the interface of entity. We need an in stock property. But let's say that I would not actually restrict, or I wouldn't restrict the objects of entity to implement this every time. So I can make this nullable, and I do that by this type of syntax. I just put in a question mark after the property. Okay. So that's how you can implement nullable properties, or yeah. Other than these types of properties, we can also say that an interface might have some methods that needs to be implemented, and we can do this by so. Let's say we have here we want a method called getName, and it must return string. So syntactically, what the difference between a property and a method here is the specification of these, the specification of these parentheses. So now we know that this is a method, and you can actually see Visual Studio knows how to reason about that. We get this small cube, and then method. It says that this is a method where these are properties, and we get this sort of tool icon. I can implement this. Method here using an anonymous function. So I say getName, and for this method I want this anonymous function, and let's just say that we would return this name, and we need to, of course, return. So now if I were to use this object down here, I get the getName method, and it basically just returns the name. Yeah?
Is it also possible to set some default values or use a default implementation of the method just made on the
So we'll actually get to that in a while. So let's just go to that. Remember that this is an interface, sort of like an interface in C#, different from a class, right? Yeah. So in a class we might have a default implementation of some function which we could override, but yeah. So here in an interface we're just saying we have these properties, we have these strings, we have these properties, we have these methods rather. They return these types, but nothing more. That's the only thing we would define in an interface. We have this get method here, but we can also make a set method, and we can take a parameter, and we would say maybe this would be a value. Again, we define what type of value it is, Let's say we can either return a string, but we can also return void. It doesn't return anything. So when I would implement this down here, I can again implement an anonymous function. I know that I get a value as my input, so I could set this.name equal to my value. I don't have to return anything because this is void. So this would be fine. Yeah. Fine, I think. Let's just see. Yeah, everything is good. If I would change the return type of this method to maybe string, then we should get an error up here. And it says that the type void, which is what this set name implementation down here returns, it's not assignable to type string. So you messed up. Go fix it. But typically for these setter functions, we don't actually return anything. We just set it and forget it, right? So we would say return void. Good. So are there any questions related to interfaces? Is it obvious why they're so awesome? Why they can give us a lot of value? Okay. Yes, I hope that is very obvious. Let me just check what this is doing. Okay. Let me check my demo script again. What would I like to show you now? What would I like to show? Okay, show in the TypeScript playground is what I would want to do next. So let's just copy all of this code, and let's say that you are someplace where you don't have Visual Studio, but you still want to play around with TypeScript. You could go to TypeScript's website, which is typescriptlang.org. And there's some different stuff in here. I think one of the most interesting things is the playground, where you on one hand can type TypeScript, and on the other hand you get the JavaScript that is outputted. So remember what I said in the beginning, TypeScript compiles to JavaScript, right? And you get that right here. So if we were to take all the code that we just wrote, I copied that into my clipboard. So if I just paste this here, yeah, we can see all of our TypeScript code over here, and this is the resulting JavaScript. So now this is a little interesting. You see, we have this interface up here, which allows for our IDE to reason about the types of our objects. That doesn't exist in JavaScript, so it just gets erased, basically. There's no reason to have it in our output JavaScript. Because the output JavaScript is not what we're going to use. It's not what we're going to work with when we sit and develop this in Visual Studio. We just need this information at development time, so we can, as I said before, reason about the code. But there's no reason to have it once this application actually runs. So this sort of gets erased. Let's take a look of the E object we have here. The type here gets erased, but other than that, this is pretty much the same, right? There's actually no difference here. And this is one of the really cool things about TypeScript, because it is actually taking the TypeScript you wrote and compiles it to JavaScript, but it's still your code. It's not some obscure, weird looking thing. It's still your code that you can go ahead and read, and it's very similar to what we actually wrote in TypeScript over here. Same thing goes for the function. Let's compare these two. So we have our function in JavaScript on the right and our function in TypeScript on the left. And the only thing that it actually removed is the is this type that we put in here. Okay. So it's pretty cool that it's just compiling it to JavaScript. In the case that we would have to look up our output JavaScript and I don't know, check something, we could easily navigate around that file because it's just what we wrote, basically. There are some cases where the syntax in TypeScript gets compiled to something that looks a little bit weird in JavaScript, but for the most part, we try to actually just compile your code and make it look like you wrote it in the first place. Good. Yeah. So now we wrote this sort by name function, and now let's actually try and use it. So let's imagine that we have some sort of a catalog with some products, and we will not say, we will not say that this is specifically an array of type entity. We'll just make some array here. So let's start off by an empty array, and then let's add some items. So let's say that we have a product. We need to give it a name. Yeah, let's give it a name. Let's say we had a guitar before, so let's say we have some drums in stock. These drums cost 999.5, and let's give it a third property, maybe the origin. Oops. Origin, let's say they come from Denmark. Okay, so this is one of our products. Let's add a few more products because I want to show you how it can sort these. Let's add maybe we'll sell a piano in our store. The price for this piano is 549.95, and this piano comes from Germany. Let's add just two more. What other instruments should we sell? A bass guitar. Okay, good. So we'll have a bass guitar. And what should it cost? A good price for that? I don't know. So, sorry? 149, good price. Cheap bass guitar. Where should it come from? Any good? The US? Okay, the USA. Good. And then any last one? Just one more? A triangle. Awesome. Is that how you spell it? Triangle? Yeah, 10. This is a cheap one, right? And this comes from China. Right? Good. So we have this array of these objects. It doesn't really this doesn't structurally implement any specific interface that we have, right? So we just have this plain sort of JSON notation for this array of products. And as you can see here over on the JavaScript side, there's nothing different. It's the same, right? Let's say that now we would want to use our sort by name function to sort these by their name. So so the first object after being sorted should be bass, then drums, then piano, and then triangle, right? So we could say we will have a sorted. We'll just call it sorted, and we'll say sort by name, and we'll say products. Yeah, where does this complain? Okay, let's actually just delete some of the stuff we have up here. Oops, like this. And let's just for now say that the only property we have in our entity interface is just the name. So now this is totally valid, right? Because we have this array of products. We didn't specifically say that this is an array that implements the entity interface, but it structurally does so because all of these four products do have a name property, and that's everything that's required for it to be to implement the entity interface. So the sort by name function is happy. It receives this entity array, but there's also a problem here, and we can actually see that in the tooltip we get. So the function sort by name, it takes an input that implements or that is of type entity array, but it also returns an entity array. So if we were to look at our sorted products here, and let's just take the first object, and this is 0 base, so the first object is at index 0. And if I press dot here, I can only see the name property, right? And that's because the sort by name function took this array and it just produces an entity array. So it sort of threw out the two other properties that we had for each of our objects. And that's obviously not nice, right? So what can we do about that? Well, all the C# developers in here will know that there's an awesome feature that came actually a long time ago now in C# called generics. Is everybody familiar with generics? Yeah. Generics exists in TypeScript 2, and it's freaking awesome, to be honest. And the problem we have here, where we cannot look up the other properties of our products objects here, well, we can solve that by implementing generics. So rather than saying that this function here takes an array of type entity, we'll just say we can take any type, right? Right. We can take any type, and it will be okay. Okay. So if I go back down here and I do the same thing I just did before, I take the first object of our sorted array and I press dot. Now we suddenly get the two other properties, because the sort by name function now respects the type of array that comes into it, and it returns the same type of array. So this is great use of the generics feature. However, we have a small problem now, and that is the name property does not exist on type T, and that's true, right? We cannot be sure that this actually exists, that we actually do have a name property now. This would still work. The compiled JavaScript would still work, because JavaScript doesn't care whether something has a property or something, because it's not strongly typed, right? But we want it to be strongly typed as we sit and develop it. So we can actually restrict the type here a little bit, and we can do that by saying, okay, this function takes any type of array as long as it extends the entity type. Great. So now we can for sure know that X, or this object that we get in, well, this object we get here, we know for sure it has a name, because it must extend or it must implement the entity interface. It can have more properties. We don't care about that, as long as it just has this name property, because that's what we need to sort it. Okay. So now if we could actually write out the result of this sorted array to the DOM. So let's just do that. We can say JSON stringify. We'll take the sorted array, and let's just run this. There's this run button up here, and we can see we get this array sorted by its name. B is the first letter, then D, P, and T. And note that this was not how we didn't put the drums or the products into the order in the array like that. So the sort by name function actually does some work for us, right? Everything is sort of good now, but I want to show you another cool feature, and that's how we can implement callback functions. So right now our sort by name function can only sort by its name. That's sort of hard coded into the function. But let's say that we wanted to create a function that could sort by another property. So we can do that by saying this function actually takes another input as well, and that's a callback, which must be of, we get some item of any sort of type, and there is return any here. We should have a colon. Yeah. So now we get a complaint, and that's because we tried to sort by name, but we need to hand it a callback function too. Let's actually redo our compare function here a little bit. Let's say that we have this kx is equal to callback of x, and then y is equal to callback of y. It will make sense in a little bit to just hang on. So we'll return if kx is larger than ky, we'll return 1. In case it's not, and kx is less than ky, then we'll return -1, else we'll return 0. Okay, so we need to hand it a callback function of x. So we get x, and then we need to return something. And what we actually want to return here is the name of the property, right? Or actually, rather, the value of the property. So we could use lambda functions here, and I'll give you an example. So we take x, we use this fat arrow syntax, which will also come to ECMAScript 6. Okay, and so what we say, we give it this sort of anonymous function in this lambda syntax here, saying, okay, I get X, I'll just return you the name, the name of the property, and in this case, the name of the property is name, and then when this callback function is being evaluated, this variable here gets the value of the name assigned, and then it can compare based on that. So it's actually not different from what we did before. We just wrote the syntax in a little different way. If we run this once again, we get the exact same thing, but now we have the cool feature of saying we can sort by something else. We can sort by the price, and if we run this again, now we have the cheap triangle first, then the bass guitar, then the piano, and then the drums. Right? It's pretty cool how you can do this, I would say. But let's actually make it even cooler. So let's say that rather than supplying a callback function, we would want to make this function, this sort by name function, even cooler, and allow developers to enter the name of the property that we'll use for sorting as a string. Okay. This, of course, does not work because string, like something of type string, does not work as a callback function here. So we'll have to do something different. We'll say either we get a callback function of this signature, or I think we need make sure I get enough parentheses. Yeah. Wait, yeah, like that. Or it can be of a string. I just need to make sure. Okay, this looks good. So we get something. Here, and I'll just call it key instead. So we get a key that can either be a callback function or it can be a string. When we look inside of our compare function here, we get we get an error because it might be that this is actually a string and a string of X. Like, what the heck is that? So we need to specifically say what our callback function will be here, and we can do that by saying, okay, if the type of key we get is actually a string, well, in that case we should return the key like that. Otherwise, if it's a full callback function, we'll just return, or we'll just put that in there. So now this should work as well. We'll run this. It works the same way. We can also say we want to sort by origin. And now it's C for China, D for Denmark, G for Germany. So we can sort by that. We have now two ways of actually doing the exact same thing. This, of course, would return the same as just before. Right? So we have this option, or we have this. Yeah, it's possible to do this type of thing we did here in TypeScript, saying that we get something of a type. It's either one of the two types, and in case you do this, you do need to check what type it is, and then do this sort of trick that we did right here. Okay? Does it make sense? Good.
Now the type and the input doesn't exist in
This here? So we can yeah, because so the callback function that we changed, it doesn't change the type of well, it doesn't change the type that's being returned. It's just changing how we're comparing the things here, right? Good. Let me just check what I would want to show now. Yeah. So let me just switch gears a little bit, and then just talk about this last line I wrote here. So I'm sure that everybody knows document.body, right? And I'm sure most of you have memorized what kind of properties it has. So I assume that many of you are front-end developers, so you know, of course, that document.body has, for example, inner HTML or inner text, and you can set that using the equal assign operator, right? It's pretty obvious. But but not everybody. But there might be cases where you would not know exactly what types of functions or rather methods or properties that something in JavaScript might have, and where you would have to look it up somewhere, right? I'm sure everybody has tried to do this. So TypeScript comes with these types of, they're called definition files that define the interface for something. And let's just take a look at that inside of Visual Studio. So we could take some function here or some method that comes with the JavaScript library. For example, sort. Sort exists on all arrays, and you can either give it a compare function. That's why you can see that it says method array entity dot sort compare fn and then this question mark. So either we can give it a compare function or we don't, and in case we don't, this sort will just sort the objects by alphabetically based on their ASCII characters, right? Okay. So, but this information, this tooltip we get in here from in Visual Studio, it actually comes from someplace, and we can right-click here and we can say go to definition. Does this seem familiar for C# developers? Yes. Okay. Good. So we click here, and we are being sent into this function called lib.d.ts. So we have a lot of these files called .d.ts, and they're definition files for something that's written in JavaScript. That could either be the JavaScript library like here, or it could be any other popular library that you might use, jQuery, Angular, anything of that nature that's written in JavaScript, and that you can't really reason about because it's not strongly typed. But then we have this definition file that sort of sits on top of the library and explains a little more about the methods and properties that are inside of this library. And here we have an example of the sort function. So this says that the JavaScript library, it has a sort function. It can take a compare function, but it's also okay not to give it one. But in case that you do actually give it a compare function, it needs to be of something, or it needs to be some function that takes two parameters and then returns a number, right? And also this sort function, this whole thing, it returns an array of some type. Okay, this is what it says here. We can also read it here. It says sorts an array. So let's just look at this very line here, and then look at what it says on the second line in the tooltip, sorts an array. This is where that text comes from. Okay, it comes from this .d.ts file. And also we get an explanation of the parameters. So a compare fn is the name of the function used to determine the order of the elements. If it's omitted, the elements are sorted in ascending ASCII character order. And you are all very experienced JavaScript developers. In fact, you're all experts. So of course you would know this, right? But if we actually scroll all the way down to the bottom, of this file, we see that there's 14,000 lines of explanation for the JavaScript library here. And I trust you to be very intelligent, but 14,000 lines, it's a lot of stuff to remember. And here you get it right in your development time experience, because as I've said before, the IDE can reason about the code and specifically about the library you're using, which in this case is the JavaScript library. I'll show you a really cool repository on GitHub. It's this one. Let's just scroll to the top. It's called Definitely Typed and is made by this guy called Borishenko, but it's really become a big thing with a lot of committers. You can see we have 770 contributors to this repository, and it's basically a compository of a bunch of different .d.ts files for all sorts of libraries that are popular in the web today. We see here we have Angular UI here. We can scroll down and we can see we have something for Backbone. We've got stuff for, there was something called Bootstrap here. What more do we have? Cordova, if somebody has used that. Yeah, so basically all of the popular JavaScript libraries today, in fact more than 90% of all JavaScript libraries today that people use and love, jQuery, Angular, Backbone, whatever it might be, there is a TypeScript definition file for that, and you can go ahead, download that .d.ts file, reference that in your project, and boom, you get types for your, and you get IntelliSense for your libraries you're using. Yeah.
That's TypeScript really do process code. It's something you need
So TypeScript sort of just assumes that whatever you're running, whether that's Internet Explorer or Firefox, that place supports ECMAScript 5. So that's the assumption, because that's what it compiles to. So it can't really do more in that sense. So, yeah. Yeah, you could do that. Yeah. Yeah.
You see a little bit about implementing space.
Yeah.
Not just large-scale projects. A bunch of interfaces.
Yeah.
You will probably want to implement more than one interface.
Yeah.
Or one class.
Yeah.
Is that possible? Like with the normal command situation? How would you do that? You have to extend the interfaces themselves.
Can you do you have any specific example? Because
if I have a class, and I would like to implement two requests at one time.
Yeah.
How would you do that in TypeScript?
Yeah, so you could do that by saying extends, and then you would write the first name of the first interface it would extend, and then the second one separate. Yeah, exactly, separated by comma, I should say.
Okay.
Yeah.
I tried doing that with some tests.
Yeah. Yeah. Okay. Let's take that. Let's take that afterwards, because I see that I just have 10 minutes left, and I really want to show you something. So as I said in the beginning, I'll take it with you afterwards. So as I said in the beginning, the session description for this presentation was that we were going to build an Angular app. We haven't touched Angular yet, and I think I will just show you some of the cool stuff that TypeScript can do for you when you develop front-end applications, and in this case using Angular. So I'll just shift gears a little bit, and I promise I'll get back to you. And I'll show you a website called To-Do MVC. Does anybody know this website? Okay, it's a bunch of guys that made this application. It's sort of a to-do list, and then they developed it using many different MV star frameworks, and this star. Well, they're like MVVM frameworks and MVC frameworks, and they took a bunch of the popular ones and implemented the same app, but using different frameworks, and they made all of this publicly available through GitHub. And the idea is to show like the same app, how does it look using different libraries, right? So what I did here, I went to their GitHub profile. You can go in here, and I took a look at the examples they have, and these are all the examples implementing the same app, writing the same app using different libraries. And I scroll all the way down to the bottom, and here we have something called TypeScript Angular. So these guys wrote their to-do app using TypeScript and Angular, and I downloaded that and I put it into this folder. And I made my own solution file. Let me just open it from in here. I think I just opened it recently. Come on, Visual Studio. Come on. Okay, here. Well, recent projects. But did I open it in here? No. Well, just okay. Here it is. Let's just first take a look at what it actually can do. Okay, I've got a bunch of files open, but let's just open this in Firefox and see what it looks like. Okay, good. So we have this. It's maybe a little light. I think I could turn. Can you see it, or should I just? Okay, fine. So it just has a big text box here, and it says what needs to be done, and then I can say something. I can say something I need to do. I need to deliver a great demo, and also I need to network with cool guys, and also I need to drink beer, right? So I guess you can sort of, it's pretty obvious that this has been built with some sort of front-end library because it's very fluid. The types of things that I enter is being put into the list straight as I type them. And I'll show you the code behind that. So let's just stop this for a while, and let's take a look at the solution. So it has a bunch of different files that you would typically have in an Angular app. How many people in here have worked with Angular? Okay, some people. Does everybody know what Angular is? Or I'll try to ask. I've learned a new technique. You should not ask that type of question. You should say, is there anyone not knowing what Angular is? Okay, I assume that people know what it is. So in an Angular app, you would typically have controllers, directives, and models, right? So these are the things that you would have in an Angular app, even if you would just write it using plain old JavaScript. I'll show you one reason why TypeScript is cool here when we are building Angular apps, and specifically, I want to change this to-do item a little bit. So back when I was entering the to-do items or the things that I had to do, I entered the title, and then it assumed it to be, or it assumed my new to-do items to be false as I created them, based on this to-do item here. It has a constructor, and we actually didn't touch upon that, but just like C# classes can have constructors, TypeScript classes can have constructors too. The cool thing here is, or I think I've showed this, but a cool thing is that we can go and see what actually references this to-do item, and we get a bunch of places here. This is something that cannot be done using regular JavaScript, right? Because what would the IDE have to do? Well, maybe copy this item and then make it, I don't know, search all files for this item. But that doesn't guarantee that it's actually classes or objects of this class that it will find. This can only be done because this is strongly timed, okay? So I get this list of 12 matches, and I can see everywhere where this is used. And let's try to go to this method here. It's called this to-dos push, and this is the method that's being called when I create a new to-do item. So as we can see, it instantiates a new object of to-do item. It puts in my string here or whatever I wrote, and it said, okay, it's not completed, it's false. So let's say that I would want to extend this constructor a little bit. By the way, can I show this? I have 4 minutes. Okay, I'll show it quickly. So we can either just say that we have properties for this class right here. We can say title and string, and then we can say to the constructor, whenever this object is being constructed, we need a string. But because this is so common, we can also just say public here, right? So when we say public title string in the constructor, it's also defining a property for the class. Let's just add date. Let's add a date to this, date created, and it's of type date. Good. And let's make sure that whenever this is being created, we actually put in the date. And we can do that once again if we say find all references. We take this method, and now we get a red squiggly line here. Why do we do that? We're not putting in a date. So we can do that. We can say new date. Yep, and it's good. And then in our view, which we have here, we can say, where do we have it? Where is this list? Can you see here? Where do we have it? To do, I think this is it, right? Yeah. So in our list here, let's say we would also want to write out our date, and we can do that. This is Angular syntax for the people who don't know it. We can say created date when we run this once more. And I say, I also need, what do I need to do today? I need to drink water. Ah, something's not working. Did I call it created date? What would I do? Yeah, stupid. Okay, let's say I also need to eat food. And now we get our date here, right? So this whole idea of a strongly typed language or superset makes so much sense, and it has made a lot of sense over the course of the past 20 or 30 years, and people have sort of accepted that in the server-side world. I don't know why it's become acceptable in the front-end world to work with crappy tools based on dynamic languages, but we're trying to sort of fix that with TypeScript. And now all my time is up, but I hope I really convinced you that TypeScript freaking rocks, and you all need to go home and work with that. Yeah, that's it.